shell of an Android app, which of course means it's quite a bit of code because it's an Android app. And Android apps often have lots of code inside. But you can see the controls I described earlier where we have a spinner, a drop-down box for picking the language we want to speak and understand. We have a record button for recording an audio clip, and then any translated text to the global chat room essentially will be put here. So what we've already done ahead of time is I've already written the code that does like the recording, like taking the bits out of the media recorder and bringing them down to a local file on the Android device and all that kind of stuff. I've also gone ahead and set up all the Gradle dependencies for Firebase because that's not terribly fun to watch and sometimes it can take a while to download. So when you're going to get started by adding Firebase, actually taking a step back, this is a kind of a general flow I'll use for building applications if I'm going to be using Firebase, is I'll kind of wireframe out just the front end. I'll get the front end, I'll get it looking the way I want, and then I kind of get it working locally, like without much real behavior. And then I kind of add Firebase into it to wire the UI components directly into the real-time database. And then before I know it, the app's just kind of already working, which is pretty cool. So if I'm going to be doing that, if I'm going to be starting from this like UI wireframe, the first thing I'm going to be doing is pasting in some code that will go and get an instance of the different Firebase components I'm going to use. So I'm going to be using storage for the binary files. I'm going to be using authentication for doing all the authentication handling, and of course the real-time database for moving all that fancy fun state around. Then I need to be able to handle, the first thing I want to do is I want to write all the data to the different Firebase services I'm going to use. So I'm going to be uploading a file to Firebase. So what I'm going to be doing here is I'm going to be using the references that I've initialized in the onCreate, and I'm going to come down to this upload file method, which it's called when the button gets pressed and the recording finishes. And I'm going to set up the references. So what I'm doing here is I'm getting a couple different references. First, I'm asking that storage instance for a reference, kind of a handle on a directory, to a directory in cloud storage called uploads. So just give me a handle on the uploads folder. And this is going to like establish the sessions and get everything ready to start moving data back and forth. And I'm also going to ask for a reference to the real-time database. And what I'm going to do here is you can give it a path to any subtree within that database. I'm just going to refer to the root uploads node. And then I'm going to call push. And what push does is it gives you a monotonically increasing globally unique identifier. It gives you a database ID. And this one is appending it to that path so that everything I write will write to that location. And what this allows me to do is have many clients that are writing at once and have all the stuff go in serially. And the client library will take care of like correcting for clock skew and all that other not fun stuff. So with those database references in hand, I'm going to upload the file to storage. I'm going to take, and I'm going to upload it. I'm going to name it. Well, first, OK, so I'm getting an upload ref, and I'm naming it based on that monotonically increasing identifier that I got from the real-time database. I'm also going to configure some metadata on that file. Then I'm actually going to push the bits up to the cloud. I'm going to get that recording from the local file system. I'm going to associate that metadata that I defined, saying like the content type and that kind of stuff, so that I know how to transcode it later. And the first thing I'm going to do is add a handler that will respond to failures. So if for some reason I am unable to upload, this method will get called. So this could be because of like something that happened on the network. Could be because of an authentication failure. Anything that caused it to fail will trigger this. And it passes in an error object that I'm not actually using. I'm just toasting a message that says I'm sad. Then I'm going to add another handler. And what this handler is going to do is it's going to respond to a successful case. So in the case that I'm successful in uploading the binary of the recording, then I'm going to create an object, just a POJO, which I should probably convert this to one of those wonderful Kotlin data classes, but I haven't yet. So I'm going to create a recording object that's just a POJO that I'm going to put a bunch of the metadata about that recording into. Then I'm going to take that and I'm going to write that POJO to the real-time database. So it's going to get sent up there and it's just going to get broken down into an associative array of stuff in the real-time database. And I can use that for downstream signaling. So let's go ahead and run this application and see what it looks like. So we're going to run it on my Pixel. And let me bring up the database viewer for the real-time database, and let's see what happens when we try and use this application. So the Gradle build is running, so we'll do the dance while that happens. So when I fight with my coworkers and foam swords, like that comic Once Upon a Time said. And now we're installing the APK. This will happen a few times during this talk. Okay, so our application is running now. So when we hit record, it should be able to upload something to the storage, and then it should be able to, we should see it appear in the real-time database if that's successful. And my app crashed. It says it keeps stopping. Oh, I think I forgot to log out after I rehearsed. So let's go see why it crashed. And it says, illegal state exception on the recorder. Uh-oh. I think Android forgot about some permissions I had set ahead of time. So I'm going to take just a moment troubleshooting this before I go in and move on to the next step. And then we'll fix this after the fact. So this is under, so it's asking for an application. We app permission, because I was lazy and didn't actually add the code that does the permissions the way you would expect. So it's up there, and it has the permissions for recording. So why are you grumpy, app? You were fine this morning. Let's give it one more kick. Okay, so we're gonna pretend that worked, and we're gonna keep on moving. Because the thing that would happen if it was cooperating is it would pop up the message that said it's sad. So if we go back down here, it would say, where did that method go? So we're below on create. We're down here in the upload file method. So what I hadn't done ahead of time is my backend was already configured to use Firebase authentication. I was requiring clients to be authenticated as a user to be able to upload data to storage, as well as to be able to write stuff to the real-time database. So because those were set up on the back end and I hadn't actually authenticated on the front end, it blew up in a little fireball and should have just toasted and said, I failed to upload the audio. So the next step for that is to go up ahead and add authentication handlers to our app. So we're going to go up and we're going to add that, and we'll see if this fixes my application, which I don't think it will, but we'll find out. So we're going to go back up onto the onCreate method on our Android app, and we're going to set up authentication. And the way Firebase authentication works is just the regular Firebase authentication libraries provide kind of low-level handlers for doing like all of the different passing of chunks of data around and keys and all that stuff to do the authentication. But they don't have a strong opinion about what the UI flow should be. So you'd have to kind of like, which makes it great for integrating into a UI flow you already have or styling it like the app the way you want to style it. But that's not always the case, especially if you're just hacking out an app quickly. So in addition to that, we have something called Firebase UI, which is a set of kind of default implementations for the UI flows for a bunch of different Firebase things. And I use this a lot for the authentication stuff. So the way they work is they will, for Android apps, they will, if you are not authenticated, you can start an activity that will handle the authentication flow for you. So what you do is you use the authentication handler to determine if the user is currently authenticated. And if the user is not authenticated, it's going to be equal to null. Also old-timey. And if the user is authenticated, then we can have our app behave as it would. In this case, we can have it listen for translations. But if the user is not authenticated, we want to authenticate them first. So we're going to put in a code snippet that takes care of that for us. So what this code snippet does is, it's a wide snippet. Anyway, so what it does is it goes and it calls a method on Firebase UI to start an activity for result. And then it will create the activity, or rather create the intent to create the activity that does the authentication flow for us. And what you do here is you set the different providers that you want to support. So in our application, I want to support email and password login and Google login. But I could put other ones there for Facebook or for my own SSO provider, that kind of stuff. So let's see if it just magically starts working again when I hit the run button. Otherwise, I'm going to go to the other app, which I've pre-prepared on another package name just in case this kind of thing might happen. Funny how that happens, isn't it? Hey, at least it starts. Hey, it actually started. I can at least show you the authentication flow. So I was not authenticated with this application, so it immediately took me over to the login flow. And this is the default thing. I can actually put some other metadata on the authentication flow to give the user some hints on the screen, but I didn't bother doing that. So we can authenticate. I can authenticate as my user, mimingcodes@gmail.com, and it's going to take me back to the application. And then we will see if it lets me record now, if it's magically started working. Nope, it stopped working already. Hopefully the other one works. Anyway, so now I'm authenticated, so I should theoretically be able to write objects to the real-time database and to storage. So let's actually see that in action on the other prepared application. So, this one's still recording. Oh, because the microphone. Someone just told me that I had another application that had been recording for hours, apparently, which locked out that resource and then triggered a case that I did not anticipate in my application. Because mobile development can be hard sometimes. Let's see if that fixes it. Hello, world. So it won't actually translate anything yet, but we see that it was successfully uploaded. And we see that it appeared here. And this is the metadata about the file I uploaded. And if we go over to storage, we can see that there's an uploads folder with a bunch of files in it because I forgot to clear them out. But you can see that there's one from right about now. It's about 4.7 kilobytes of me saying hello world. But our application has not actually responded to it. So I've sent data up to the cloud so I can do stuff up there. But my application's not reacting to events in the cloud yet. I'm only writing data. I'm not reading it. So let's implement that part next. So what we're going to do is we're going to go down to this listen for translations method, which is the method I call when my application is set up and it's ready to start receiving data from Firebase. So listen for translations. What we're going to do here is grab another snippet of code, and we're going to do something we do a lot when we're using the real-time database. We're going to get another reference to a location on Firebase. This time, we're going to listen to the path translations, which is where all the translations are going to end up. And in the next snippet, what we're doing is we are adding an event listener. Let me see if I can make this a little wider. Fighting visor here. It does not want to today. It is a silly thing. Anyway, okay, so here it is. You can actually see all the code. So what this one is doing is we're doing a query against that tree. Specifically, we don't care about the stuff that was uploaded an hour ago or a day ago, because it's all going to be up there. We only care about the stuff that people are currently doing. So we're going to add a query, a very simple query, to the limit to the most recent one object that's been uploaded to translations, or it's been written to translations. So what this will do is when we first connect, we'll get the one most recent one. And then as people continue to use the application, we're going to continue to get callbacks called whenever another one of those things appears. Every time one appears, it's going to send us one down. And it is a child event listener, which means that we're going to give the path just above where we want. And it's going to give us, whenever a new child is written up there, we're going to get callbacks for a variety of events. So there's a bunch of events that I didn't bother implementing, but in production I actually would. Like for cases when the children get deleted, what should I do? Should I display an X on the screen? If the child is changed, but we're just doing the child added. So we're only handling the case where a new one is written. And what we're going to do is, in this method, which just gets called whenever a new object appears, the first thing we're going to do is take the snapshot. The snapshot comes in whenever you get a kind of a read event from the real-time database. And it's an immutable snapshot of the data at the time the callback is called, at the time the event occurred, essentially. So if things change while your callback is running, it's still going to stay the same, because otherwise that would be crazy. And it has a bunch of metadata in there. One of the pieces of metadata is the key, which is going to be the same key that we defined way above on that push method as to propagate it through the system. And then once we have that key, we're going to listen for the language that we have picked on the spinner. So let's go down into here and let's implement that. So what this one's doing is it's null checking the translation key. If it somehow gets called by a null one, it won't do sad things. And then what we're doing is we are creating another listener. So we're taking the language that our application has selected and the key that we got from the previous method, the previous listener, and we are listening for translated text to the language we have configured. And this is a model you will do a lot, is you, as you build out this kind of stuff with the real-time database, the subtrees that you care about will change a lot, will move around based on events in your application. And the listeners themselves are actually very cheap to construct. So it's not unusual for a more feature-rich application to have hundreds or even thousands of listeners. Sometimes they'll be changing changing on the second or minute. They're very cheap as part of the way the client library is constructed. So don't worry about creating a bunch of listeners. But try not to leak them. If you leak them out, you end up syncing data you might not want, and you might be sad then. So then what we are doing with our listeners, we're adding a value event listener. And the value event listener will, so the previous one listened for when any children got added to the node just below. This one is listening to changes in the state of anything in that subtree. And whenever anything in that subtree changes, we're going to get a snapshot of the whole subtree sent back to our method. And what we do here is a pretty simple thing. We get the data out of the snapshot as a string, and then we pass it to the platform, the Android native text-to-speech. So let's go ahead and see if this runs. The APK install. It's getting faster. It's funny how that happens. So now what we can do is we don't actually have any of our translation stuff written yet, but I can totally pretend to be it. So I'm using this database viewer to add it, and we need a fake key. Then under that, we are listening for, it's currently selected is English. And then, hi everybody. And hey, it appeared right there, which is pretty cool. And it's a value listener, so it'll respond to changes automatically. So I can even change this, and it'll change pretty fast on the client, which is pretty cool because this one's going over wired Ethernet, and that one's going over conference Wi-Fi. So it moves pretty fast as a round trip to the Firebase servers, which is pretty neat. Okay, so now we have our client, which works and can both read data from Firebase as well as write it, or can write data to Firebase, the metadata about the upload and the binary data itself, and it can also respond to changes in the real-time database. So, we're done. We trained machine learning APIs, which are really just kind of a REST API. It's not that new anymore. It's getting close to a year old now. But it's really fun for dealing with problems just like these. It's cloud functions. So because we're just doing a small amount of brokering and have a small amount of secret data and not really that much complexity in the cloud, but potentially big spikes of scale, cloud functions is a great way to solve our problems. So let's switch over to another language, away from Kotlin land, away from Android Studio. And let's bring up IntelliJ. And let's write some cloud functions. So this is kind of where you would start if you were writing a cloud function that used this stuff. We have a bunch of dependencies we're pulling in. Yay! Cloud Speech API, Cloud Translate API, all of our different API keys for making those calls, and one little boilerplate method for handling the different representation of language codes between iOS and Android. But we get started. We have very little boilerplate code, which is kind of cool. It's a neat place to start because you can basically start with an empty file, which is something you don't see a lot on platforms these days. So the first thing we're going to be doing is we are going to be creating a JavaScript function because it is Cloud Functions, right? And this function is going to be, when you use Cloud Functions with Firebase, there are a bunch of different events you can respond to. And the Cloud Function will be called whenever those events occur. These could be like webhook events, like you have a URL, when it gets hit, the function runs. But there's also some that tie into different parts of Firebase directly. So for this one, I am writing something that is triggered when there's an event on the real-time database. So it's a database trigger, and then I give it a path, a subtree, that I care about. So whenever something happens on a path that matches this query with a wildcard, the function's going to get called. Specifically, whenever something happens on the uploads node with any identifier, it's going to call this function, specifically when it sees a write event. And writes will include changes as well as new creation. then it's going to give me an event payload that contains a bunch of goodies. The first thing I'm going to do is unpack that event payload and put it into more convenient to use things. So the payload is going to come with, for example, the language and the sample rate and all the other stuff that's within that node. So what I'm doing is I'm reading the object that got passed into the function from the database. The next thing I'm going to do is take that data and remunge it into a slightly different format. So I'm going to take it from my mobile application format that I push to the real-time database. I'm going to change it to a format that I can send to the speech API. So I'm unpacking bits from one format, packing them into another. And then I'm going to point the function at the recording where it lives in cloud storage. So I don't have to actually download the data, like I don't have to pass it through or anything like that. I can just point it to the location I've already uploaded it. Then I'm going to run my recognize event. And that's going to give me a promise. So when that returns, then I will have the recognized transcribed text. I'll take that, and I will get another reference to a location in the Firebase real-time database. And I'm actually interacting with it through the admin SDK because I'm running in a trusted environment, which allows me to bypass a lot of the security rules and stuff like that. Because this function is in a trusted environment, I'm giving it access to all of my real-time database, which is not a pattern you have to do, but it's something that can certainly be convenient. So that's why I'm using admin ref here, just as out of convention. And then I'm going to write the transcribed text as well as the language. So with that written, it's going to write the transcription to the real-time database, and I can signal the next thing. Oops. So this is where the pattern I use a lot when I'm using Cloud Functions to solve these problems. I can chain them together. So I've just written a transcript down, which is not yet translated. It's still in the original source language. But what I want to do is I want to hear it. I want to have an event that I can trigger it to send it to the translation API. But I don't want to have one big monolith of code. I want to break it into pieces. So what you can do is you can have Cloud Functions that kind of chain together. Either they will send an event to the next one directly, or in this case, I'm sending an event through something that changes in the real-time database. So this is another write event handler on the transcripts node. See, where was I? C6. Pasting in another snippet of code. So what this one's doing is it's doing the same thing we did above. I'm going through and I am unpacking the data, and I've hard-coded the languages that my application supports. And then what I'm going to do is I'm going to do basically the same thing I did before, except kind of like a promiseified loop. What I'm doing is I'm mapping through all the languages I support, and then in parallel, I'm sending a request to the translation API for all of the languages I support simultaneously, because why do them serially? Why wait? There might be some client currently using that. And then for each one of those, if the translation is successful, I'm going to write the successful translation to Firebase real-time database. Currently, I drop the promise on the ground if it fails, but I could put an error handler here, like a catch, that would write an error event to the real-time database. So at the end of the function, because I just forked off a whole bunch of promises, I have to add promise.all to wait for all of them to finish running so I can finally exit the method. If I don't do this, the function will exit immediately, or maybe it'll never exit. It'll exit when it times out after like 60 seconds. So you want to make sure that you clean up all your promises when you do this and return an individual promise that terminates, that reaches the state transition at the end of your actual work. Otherwise, you can end up with unusual behavior because promises is crazy like that. It's still a language construct that I'm like kind of using effectively, but it is powerful. So let's go on back onto the slides. Boop. So at this point, I would deploy that Cloud function. I've already deployed it ahead of time to save a couple minutes so we can spend more time on the fun demo. But this is basically what it would look like. You use the command line interface to deploy the function. It's going to push up my functions to Cloud Platform, and they will be there ready to serve requests. If it has a webhook, it'll also tell you what the address of the webhook, the web trigger is. So with that done, let's all play with the app together. So I'd like all of you, whether you're home on the live stream or here in person, if you have a laptop handy or a mobile device, get it out, go to this URL, and turn the volume up all the way to the max. That'll make it more fun, I promise. And in the meantime, what I'm going to do is pull up, well, I'm going to go to it myself too, to show you what's there. You can pick a language on this web interface, a language you would like to hear me try to translate text into. And then I am going to write data to it from the mobile application. So let's see if this actually works. I'm going to attempt, while that's happening, I'm also going to show you the real-time database as it happens. So we'll watch the real-time database so we can see the function executions occur while this stuff happens. So I'm going to say something. Hello, world. I say that a lot during this talk. And hey, we saw the upload get written. You can see all the metadata there. The cloud functions are now running, transcribing it. It is transcribed. Hey, it transcribed it to text. And now it is translating it.
Hello, world.
Ooh, I hear a bunch of languages picked. And we see that it's translated in all of the different supported languages. And I can select a different language up here. I can even try and speak a language I don't speak. I'm going to try that. So I'm going to pick Japanese. Let's see how successful this is. Ohaya gozaimasu. So it went in, it uploaded again. We'll see if it successfully transcribed it.
Good morning.
Hey, I actually said something in another language. Yay, I did. Sometimes it translates to something else. So, did anybody pick a language other than the ones I showed on stage? A few hands went up. Did it actually successfully translate into those languages? Did it kind of make sense? Thumbs up everywhere? Wow. I guess I give it very simple phrases. Sometimes I'll try and speak something more complex in, and craziness will come out, which is pretty fun. But it definitely does stuff. So, what have we accomplished in the last 40 or so minutes? We solved a problem that I encounter in my daily life in the way I solve all of the problems in my life, by writing a mobile application. We wrote it in Android with Kotlin, which is pretty cool. I love using Kotlin on Android. It's so much nice. It's so much nicer than Java. I love Java too, but Kotlin's a good fit for Android development. And previously, I might have done something like this, where I had to spin up a bunch of compute nodes. And this may be where, if I had taken this application and moved it further along in its life cycle, I'm probably going to end up spinning up compute nodes to do more development on certain parts of the back end. But it's certainly more fun to have an existing application that's working to start from before I start optimizing different components, using different training sets, maybe writing my own translation models, or actually doing the translation from audio instead of from text, which loses some of the resolution. And I presented a different way of accomplishing that fact and getting that prototype out the door. We took Firebase, we took a few of the backend components and a few of the client libraries and hacked up an Android app pretty quickly in not that much code. And then we wired it up to cloud functions so that we could use a couple pre-trained machine learning APIs so we could move quickly. So now this is where I kind of encourage all of you. I showed you my favorite recipe for hacking out mobile apps to solve problems in my life. I encourage all of you to give it a spin. There's a free tier for all of the Firebase stuff, and you can build a lot of these things. I think all the translation APIs and stuff, like that's the cost for those. There's free tiers for those as well. So you can get this working pretty quickly. So go build cool stuff.